Right, so we've been covering linear equations and inequalities. Here's the inequality from the last video. Here's the link to the last video. And I will put it in the description below. So we were prompted to solve the inequality below in terms of n, given theta is greater than 0. And here's the solution set and its domain interval that we came up with in the previous video, which we ended up checking against Gemini 2.5 Pro. Now, without a targeted system instruction or a rigorous initial prompt that specifies a persona and formatting adherence that should govern model responses, the model punted graphing the inequality despite the explicit request contained in the prompt to illustrate its graph on the number line. So in this video, we are going to cover two simple graphing methods that can easily be implemented in a LaTeX or MathML or Mathematica workflow on Lars. The first will be the SVG implementation that I wrote in the previous video, and the second will be an alternate Mathematica implementation. All right, so let's set up the vector graphic and its dimensions. The first thing we'll do is position the graph's label just above the graph itself. Then we'll encode the x-axis. Next, we will set up a group of elements, including the graph of the inequality, shaded in blue, and the point for the least most value of n, for which we wrote the label above. Let's be sure to shade that point the same color as the graph to which it belongs, namely blue. And lastly, let's encode the arrowhead inside this group as a triangular polygon at the following points, which simply need to be transposed to the right edge of the graphic without rotation. And we're done. All right, so let's see how we can generate the same graph in Mathematica. Okay, so Mathematica and SVG are both high-level languages, with Mathematica syntax being less isolating and verbose. We can start by setting up the x-axis inside of a graphics environment, followed by the graph of the inequality. Once again, we need to specify the least most value of n as a solid point. Then we can label said point. We can explicitly disable the y-axis, define the plot range and background color of the illustration, and let's also disable the tick marks here for good measure. Right, so let's run this script, see what we get. Essentially the same as the SVG output, with a bit of a fragmented frame, which is residually carried over by the Wolfram API, and a different font for the graph's label, where in the Mathematica code we did not specify the font family the way we did for the scalar vector graphic. Okay, so a quick update. In the previous video, we ran this problem through Gemini 2.5 Pro. Since publishing that video, Gemini 3 Pro has been released. So we will continue on with the same dialogue as before, but we are going to run Model 3 Pro from this point forward. So again, the intent of this exercise is to explicitly prompt the model, now 3 Pro, to graph the solution to the inequality, as cold prompting in 2.5 Pro did not generate a graph in the first turn, despite the explicit instruction to do so. All right. Gemini is graphing. And here we go. Okay, so the graph is valid as to be expected. Inclusivity at the lower bound is shown. The orientation of the graph is correct. I like that the label and title use vertical fraction notation. That's possible in SVG and Mathematica as well. I was being a little lazy in my scripting. The only thing I don't like is that the model defaulted to a white background in generating the image, as opposed to matching dark mode the way I've done in my solution. But most importantly, the math is correct.